Okay, you guys, this is problem number 15 from chapter 3. We have, it's on voltage divider circuits. We have a 160 volt independent source and two resistors in series, a 4.7 and a 3.3 K. And the load is the across R2. And we want to find first what is the voltage of the load, the V naught, and then we want to find the power dissipated by the R1 resistor and the R2 resistor. And then we want to solve the problem. What if we only have 0.5 watt resistors? What values should we choose for R1 and R2 if we want to keep the voltage, the V naught, to be the same? So for V naught, that's just a straight up application of the voltage divider, which says that it's proportional. So we have 160, we're going to have a proportional drop, which means 3.3 K will drop across 4.7 plus 3.3. And if you do the math on that, you should come up with V naught of 66 volts. And power dropped across the two resistors. Since they're series connected, they have to add up to 160. So the power drop across the R1 resistor is just going to be V squared, which is 160 minus 66 squared over R, which is 4.7 K. Do that math and you should come up with 1.88 watts. Same thing with the R2. We just found out that it's 66 volts, or 66 volts. So P sub R2 should be 66 squared over 3.3 K. And when you do that math, you should come up with 1.32 watt power dissipated across that one. For the third one, you're limited by 0.5 watt resistors. So we know that P is equal to V squared over R. So if we take a look at this resistor, if we know that it's 0.5 watts, R1, and we know this is 160 minus 66, we're saying 66 has to remain the same. We can solve for R1, and that will give you a value of 117,672. For R2, we use the definition of the voltage divider circuit. We know that it has to be, we need 66, the criteria is that 66 volts needs to drop across here. We use a voltage divider circuit, which says that we have 160 volts. We just found out, we don't know what this needs to be. That's what we're trying to find out. But we know that R1 is 17,672 plus R2. That's just a straight definition of the voltage divider circuit. Divide both sides by 160. Gets rid of that. Now we're going to invert both sides, right? This will give me on this side 17,672 plus R2. It's over R2. That's equal to 160 over 66. Now, this is just algebra from this point solving for R2. You can cross multiply and get 160 R2 equal to 66 times 17,672 plus R2. I'll leave the algebra to you. But once you solve for R2, you should come up with a value of 12. I came up with 12,445, but I did some rounding. I think the back of the book has some different values where they don't do the rounding. But no electronics teacher should penalize you for if you're off by 10 ohms. If they are, they're officially ridiculous. So anyways, 12.4 K is for R2. And that's it.